Hi friends, today we're going to be working on our lesson 1-3 notes. So today's lesson is on graphs of equivalent ratios. So what I want you to make sure you do is put your name on the very first page, up here at the top, and then on the second full page, that's the practice. So today we're going to look at graphing equivalent ratios using a ratio table. I'm going to work through example 1, and while I'm working through it, I want you to be filling it in on your packet. And if at any point you need to pause, please do so to make sure you have it all filled in to help you with the problems you're going to do with your group. So I'm going to start by reading example 1. We're graphing and interpreting ratio relationships. So it says Tala is getting ice pops for her class. Each package contains 8 ice pops. Generate the set of ordered pairs for the ratio relationship between the number of ice pops, y, and the number of packages, x, for a total of 1, 2, 3, and 4 packages. Then graph the relationship on the coordinate plane and describe the pattern in the graph. So what we need to do first is we have to decide what's the important information. And so it says that each package contains 8 ice pops. And then we're generating the set of ordered pairs for the number of ice pops, y, and the number of packages, x, for a total of 1, 2, 3, and 4 packages. So a coordinate or ordered pairs have an x and a y coordinate. And so our x coordinate in our table's on the left, and it says the number of packages. That's going to be the x. And what that means is on our graph, that's going to be at the bottom. It goes across or horizontal. And then our ice pops is this middle column. That's y, and that goes up. Okay, so it's vertical on the graph. As you can see, it says number of ice pops. And then it says we want 1, 2, 3, and 4 packages. So for our number of packages, we're going to have 1, 2, 3, 4. Okay, so fill that into your table. We're going to have 1 package, 2 packages, 3 packages, and 4 packages. So now we need to know how many ice pops are in those packages. And the problem tells us that each package, so 1 package, has 8 ice pops. So 1 package is 8. That means each package has 8. So when I have 2 packages, I have 2 packages of 8 ice pops. So 2 times 8 is 16. Okay. My third package, or 3 packages, if Tala gets those, there's 3 packages. Each of them has 8 ice pops. So 3 times 8 is 24. You're going to notice that we're just adding on 8 each time because I'm adding on 1 package each time. So when I have 4 packages, I have 4 packages of 8 ice pops, and 4 times 8 is 32. So the left side is my x coordinate, my middle column is my y coordinate. So now we're going to put that together as an ordered pair or as a coordinate, and that's going to go here on the right. So the way we write a coordinate is we're going to have parentheses. Okay, and then my x coordinate, or the number of packages, goes on the left, and my number of ice pops goes on the right. So I have parentheses 1, comma 8, end parentheses. So I'm going to do that for each one. So I'm going to have 2, comma 16. I'm going to have 3, comma 24. And I'm going to have 4, comma 32. Those are the 4 coordinates. Okay, so make sure you have that filled out as well. Now we're going to graph it on our graph. So each of these coordinates, like I said before, my x is that's the first one, that's horizontal. So where is my number of packages? Then my y is going up, and that's the number of ice pops. So for example, for this first one, I'm going to have number of packages is 1. My number of ice pops is 8, so I go over to the 1, and then I'm going to go up and I'm going to put a dot at 8. So I have 1 package, 8 ice pops. So for the second one, I'm going to go to 2 packages of ice pops, and 2 packages has 16 ice pops, so I put a dot at 2 and then 16 up. So for 3, I go across to 3 because my number of packages is 3, and then I go up to 24 because I have 24 ice pops. And for our fourth one, when we have 4 packages, we know we have 32 ice pops. Okay, so I put 4 dots for 4 ordered pairs. So again, my X was across, the number of packages. My Y was up, the number of ice pops. The very last part of this question then is we have to describe the pattern. So this was a lot like on our quiz last week. It says for every blank package, there are blank ice pops. So it's a ratio. So for every 1 package we have, there are 8 ice pops. That's one way we could fill it out. We also could say for every 2 packages, there are 16 ice pops. So we have 4 different ways we technically can write this. You just have to write one. I just went with that first one. For every 1 package, there are 8 ice pops. So now I want you to make sure you have all of example 1 done. We filled out the table, we did the graph, and then we described the pattern. So what you're going to do now with your group is on your paper, we did all of example 1. You are going to do the now you try section. So we have problem A with Jose making lemonade. And we have B, a school administrator is making 18 new chairs for each classroom. And you're going to notice that when we're starting, our X values are all the same. So my hint to you for A is you are going to start with 1 gallon, 2 gallons, 3 gallons, and 4 gallons. And you're going to fill out the table like we did on example 1. You can use the example 1 to help you. Then you'll graph it, and then you'll describe the pattern. Again, make sure you're working together so every person in your group has A and B done by the end of class. Now, if you finish A and B, you're going to not do example 2. We'll do that tomorrow. You're going to start in on the practice page. There are a couple graphing problems for you to do. Okay, if you have questions, you can ask each other, ask another group. But again, the goal is to have the now you try A done and B done by the end of class.